Could AI explore our galaxy? When we hear the term artificial intelligence, it's not hard to think about killer robots or conscious machines, such as those shown in popular movies. But what if AI wasn't any of this and could help us explore our galaxy? For the programmers and researchers, artificial intelligence mostly means learning and adaptive algorithms. Traditional software strictly follows the guidelines imposed by the programmers. For example, the programmer might write, "If the user clicks on the button, display picture funny.jpg." Instead of this linearity, intelligent algorithms are designed to learn from their successes and their mistakes. They will try multiple solutions. Once a solution that works is found, it will be used as often as possible while maintaining some exploration for potential better solutions. The process is called exploration-exploitation. The idea looks simple, but it means that the more data you have to learn about, the better your software becomes. Intelligent cars will soon have the combined experience of millions of drivers. They are learning from thousands of mistakes and are already saving lives. But why keep artificial intelligence on Earth? Scientists face a big problem when sending probes to other planets. The distance is so big that we can't control them in real time. For example, the information from a Mars rover takes 20 minutes to get back to Earth, and the command from the human controller takes 20 more minutes to go back to the rover. Imagine playing a video game with a 40-minute delay. But if probes are intelligent enough to learn, they could explore by themselves, make decisions, find resources to repair broken components, gather energy and, why not, build other probes to help them in their exploration mission. The concept of non-biological self-replicating machines was famously proposed as a thought experiment in 1948 by mathematician John von Neumann. His concept was abstract, with the imaginary machine standing in an infinite stockroom of spare parts, allowing the machine to build an infinite number of copies of itself. In 1956, mathematician Edward Moore proposed a model for self-replicating machines floating on the ocean and harvesting raw materials by themselves. But if we could build such self-replicating machines, why not send them into space? The idea quickly became popular with self-replicating spacecraft, usually called von Neumann probes. Space is so big that we cannot explore it during a human lifetime. But time is not an issue for auto-repairing machines. Von Neumann probes could build other probes that are then launched into the vast interstellar vacuum. They don't need to move fast. Hibernating for centuries when there's no star in sight is not an issue for an automated probe. In the late 70s, physicist Freeman Dyson even came up with the concept of a very small and light auto-replicating space probe weighing less than 1 kilogram. Using artificial intelligence, electronic and even some biological components, the probe could lay eggs near asteroids or moons. The eggs would harvest materials to build a copy of the original probe. While explaining the concept during a lecture, an audience member called out, "You mean this is an astro chicken?" Dyson liked the name and started to use it himself to describe his creation. Astro chickens were first thought up as a way to explore the solar system, but no further. In 1980, engineer Robert Freitas published a landmark paper titled "A Self-Reproducing Interstellar Probe." In the article, Freitas described in great length a possible architecture for a self-reproducing interstellar probe called RePro, analyzing the availability of different materials in space and how to harvest them. Inspired by the idea, NASA itself started to explore the idea of building self-replicating factories on the Moon. Factories that would automatically build self-replicating interstellar probes while expanding their own capacity using the lunar resources. In 2012, a team of NASA researchers explored what they called the bootstrapping approach, which involves starting to build self-replicating factories in space, on the Moon or on asteroids in order to use fewer and fewer resources from Earth. Resources that have to be launched into space at great cost. Former NASA chief technologist Mason Peck called the concept massless exploration, saying, "All the mass we need to explore the solar system is already in space. It's just in the wrong shape." But self-replicating space probes also have their dark side. In the conclusion of his article, Freitas warns about the ethical implications of creating such self-replicating spacecraft. Indeed, if we manage to build and launch 1,000 probes into space that are able to replicate themselves every 10 years, we would already have 1 million probes in space after only 1 century and 1 billion after 2 centuries. They would spread very quickly in the galaxy and will continue without human interaction. This may look wonderful, but as Freitas reminds us, would we be happy if an alien space probe suddenly landed on a Jupiter moon and started reproducing itself without asking for permission? Wouldn't we consider it as a threat to our planet? Dyson called uncontrolled self-replicating space probes a technological cancer loose in the galaxy. To illustrate the threat of uncontrolled intelligence, philosopher Nick Bostrom devised a thought experiment in 2003 in which an artificial intelligence is tasked with building paperclips and maximizing at all cost the production of such paperclips. The experiment shows that, without any other restrictions, the artificial intelligence will quickly use all possible resources of the universe to build paperclips or paperclip factories. The danger of self-replicating nanomachines was similarly illustrated by engineer Eric Drexler in 1986 by imagining a planet covered in what he called grey goo, a huge ocean of self-replicating nanomachines. The fact that self-replicating probes could quickly colonize the galaxy, but that we haven't spotted any, led physicist Frank Tipler to the conclusion that we are the only intelligent civilization in the galaxy. Carl Sagan famously responded by saying that any civilization intelligent enough to build self-replicating probes would also be intelligent enough not to build them and able to destroy any von Neumann probes approaching its solar system. Carl Sagan's view may be a bit extreme. Simple limits can be implemented to avoid a self-replication apocalypse. Von Neumann probes may be the best way to explore the galaxy, but we still need to learn how to build them.